Hey guys, Buildzoid here, and we're back with the 14900K on the Gigabyte Z790 Aorus Extreme X motherboard, because I had an idea for an alternative to the Intel baseline profile that, in theory, should fix instability, and shouldn't hurt performance anywhere near as much, and probably is safe for long-term use. Though I have, the thing is, I have a bunch of different configurations that we're going to go through today that are progressively more and more, they have more and more performance reduction, but they should be safer and safer. So depending on how much you trust or don't trust Intel, you can choose your own combination of settings to, minimize degradation potentially. Though, yeah. So that's kind of that. Anyway, let's go into the BIOS. So as you can see, I have the BIOS completely reset. And we're actually just going to go into Windows, because I want to show the default behavior. And as you can see, Z790 Aorus Extreme X on the newest F5G BIOS with the i9-14900K. I don't have XMP enabled because the instability is from the CPU. So it doesn't really matter if we turn the XMP profile on or off, because the CPU is the problem. So we're first going to do some baseline tests for the default behavior, which I've already showed in past videos, but I want to have everything in one video at the same time. I guess while we're waiting for Windows, I should also point out I'm not, an electronics engineer, and I don't have access to Intel's reliability data. So when it comes to the this should be safer than potentially even Gigabyte's Intel baseline profile, I'm basing that off of the fact that the settings that I'm using here run lower voltages. I don't know if those voltages are low enough to actually be fully safe, because I don't have Intel's reliability data, but the voltages that my settings end up at are a lot more in line with the vid table of the CPU than the default motherboard behavior. So anyway, let's pull up hardware info. And benchmate. And so as you can see, also for cooling, I'm using a 360mm AIO. I guess I should have maxed out the pump speed again, but oh well, as long as I keep that consistent for all tests, it's not going to matter. So we're going to start with Cinebench R23, because I would like to get a multi-core score. And 23, this doesn't necessarily always crash like 15 tends to. So there we go. We get a score of 40,518 points, which is a very high score. But we also, go over somehow. We apparently managed to slightly go over 100 degrees. Package power is 340 watts, which we're not actually really going to change this that much. Well, it depends on what kind of configuration you decide to follow from me. So let me just get the Intel documentation ready. But anyway, so yeah, so that's our baseline. And then for core voltage, well, while R23 is running, we should be seeing the voltage actually. Yeah, it sits at 1.26, 1.24. Actually goes quite low. Or 5.4 gigahertz. Because the thing is, the actual default BIOS configuration from Gigabyte runs a slight undervolt. Which isn't very noticeable for low loads. As you can see, we're hitting 1.5 volts right now, right? If I move the mouse around, especially. And that's because we're right now we're running the 6 gigahertz boost on some of the P cores. And then at high load, we're actually getting pretty low voltages, but the low voltages at high load is the whole reason that, if I try to run Cinebench 15, I can't. Right? As you can see, it just crashed. And that's because the Gigabyte default BIOS configuration has a undervolt on it. And yeah, and that leads to some other like configuration choices from Gigabyte. And I can't even close Cinebench right now because it's freaking frozen. So anyway, that's the like baseline behavior here is that, you know, in R23 the CPU scores over 40,000 points, and then you try to run R15 and R15, well, doesn't run because the CPU is not being fed enough voltage. Further proof of the fact that the CPU is not getting fed enough voltage is what happens when you turn on one of Intel's like safety features. At least according to a statement that I saw on video cards, it's a safety feature. I've not been brave enough to try any Intel contacts about this after the last couple videos. Anyway, so, yeah, basically, if we read through this, like, is this officially from Intel for the public, or is it from to the motherboard vendors? Oh, yeah, so I think this is a public statement. But anyway, so if you read through this, Intel has observed that 600, 700 series chipset boards often set BIOS defaults to disable thermal and power delivery safeguards designed to limit processor exposure to sustained periods of high voltage and frequency. For example, disabling current excursion protection. There's a very good reason for why motherboards disable this, and we're going to see that just now. Enabling the ICC Max unlimited bit, so they just disable the ICC Max functionality completely. So the CPU cannot like the ICC Max current limiting just gets completely turned off. Disabling thermal velocity boost. This leads to significantly higher idle voltages. Additional settings which may increase the risk of system instability. Disabling C states, Windows Ultimate Performance Mode, increasing PL1 and PL2 beyond Intel recommended limits. I don't think these last three actually have much of an effect, but these first four, these could be quite significant from a degradation perspective. So first, let's take a look at why it is that a typical high-end Z790 motherboard will not have CEP enabled. So I'm just going to turn CEP on just now. And the way CEP works is that it basically measures the voltage drop of the core voltage going into the CEP. I mean, into the CPU. And if it detects too much of a voltage drop, it starts throttling the frequencies. Now, the problem is, your typical high-end Z790 motherboard undervolts the CPU out of the box. So, CEP has a specific voltage range which it requires in order to function correctly. So if you turn on CEP with your motherboard's default AC load line configuration, which is an undervolt, right? So if we go over to Intel VR control here, you can see we're at 4090. This is a substantial undervolt to the CPU. And so if we turn on CEP right now, it's going to destroy performance. And a lot of the high-end Z790 motherboards do this, where they just run an AC load line that is too low. And then, because it's too low, to prevent the CPU from losing a bunch of performance, the manufacturer disables CEP. Now, unfortunately, the Intel documentation doesn't really explain how much like protection CEP offers, but if it has any kind of like per core current limiting, or like if it's just like a all core current limit, I don't know. Yeah, like the Intel doesn't really go into detail of how much like protection CEP offers. But the immediate consequence of turning it on with your motherboard's sort of random undervolt is that performance is going to be really bad. But it does fix stability. Because when CEP detects that, well, it's not really looking for the undervolt. It's like trying to measure a voltage drop to see if the CPU is pulling too much current. But if you have the CPU undervolted, it sees way lower voltage than it expects to see. It freaks out, and your performance jumps off a cliff. Apparently, oh wait, I opened the wrong version. Okay, I'm just going to unpin this. Otherwise, I'm going to keep doing that for the rest of the video to open the Benchmate version. So if we run R15 now, it does in fact run. And you'll notice that the CPU is actually reporting 5.7 gigahertz effective clocks, and that's because when CEP kicks in and starts stretching the clocks, it completely breaks frequency monitoring on the P cores. So yeah, 3,000 points in R15 is not a good score, but you probably don't have much context for what 3,000 points for R15 means. So let's take a look at what CEP does to Cinebench R23 with Gigabyte's default core voltage configuration. Also, one side effect of CEP kicking in is that because it's very confused, is like we're actually pulling quite low power. Voltage is actually quite high right now. But the thing is, like, the CPU is internally throttling its current draw a lot. You can see that the E cores are down at like 2.2 gigahertz. And the P cores aren't running at 5.7. They're running at like 3 or something. As you will see from the score, which is about half of what we... Actually, it's somewhat less than half than what the motherboard gets on full auto settings. So this is why a typical high-end Z790 motherboard will actually not have CEP turned on, because if the motherboard did have CEP turned on, then the factory undervolt would trigger the CEP constantly, and your performance would be garbage. So, you know, that's probably not ideal. So now we're going to clean up the CEP behavior. So we're going to fix, like, I'm going to keep CEP turned on, but I'm just going to fix the, the clock stretching. So to do that, now this is one part I'm not 100% certain about, but setting the load line calibration like this with CEP, I think, because of how CEP behaves, I don't think you'll be able to get the CPU to crash. Because once you have CEP turned on, I think, like, you can even set like a 200 millivolt undervolt, and the CPU will just clock stretch straight through it. So, at least if you don't try to run frequencies outside of the stock boost table from Intel. So, anyway, we're going to set load line calibration to extreme, and then we're going to manually set the AC and DCLL to match the VRM settings right now. So that for extreme, well, so DC load line, you kind of want to, this 12 might not be exactly right, because basically the point of DC load line is to get, like, the DC load line affects the CPU's power monitoring capabilities, so that's used by the CPU to calculate how much power it thinks it's pulling, and AC load line is set for actually, like, the voltage behavior. So, with this configuration, we won't get CEP, like, CEP will be happy, so it won't trigger all the damn time, but, we won't, I think the power reading might be a little low for all-core load, because the DC load line, I might be setting it a tad low. Actually, you know what, I'll just set it to 20, later. Like, the thing is, I don't think the DC load line, if you have it off by a very large amount, then that's obviously bad because your power limiting is going to be just, like, complete. Like, you're not really going to have a functional power... Well, you still will have a power limit, but your power limit will not kick in at exactly the, like, correct point at which it should. Now, one issue with the configuration I have right now is that our idle voltages are not great. Well, I mean, so far we've only maxed out at 1.45, but yeah, it should get worse under load. Anyway, so we're going to run R15 again just to show that it is still stable. Oh, we should be watching this for core voltage. But yeah, you can see that, hey, score's gone up. Like, it's basically doubled. Load core voltage dips down to like 1.259, 1.3. We're actually going to do further things to try get the core voltage under load even lower. And also I have an idea for like later in idle voltage reduction. Well, we're going to do the idle voltage first because that's just a setting that you need to turn on in the BIOS. And anyway, so now you can see that, yeah, our idle is getting up to like 1.5 volts. I'm not a big fan of that. Which is, admittedly, that's in line with the motherboard's default behavior, but we can do better than that. So yeah, 39,229 points. It's a tad lower than I would maybe like it to be, but the thing is, like, we can't, if you have CEP turned on, you can't undervolt anymore, right? So basically that like default score that the CPU was getting at like over 40,000, that was because it was undervolted. If you want your current limit, like if you want CEP to function, you can't undervolt. So there's really nothing I can do about this, because if I lower the operating voltage, CEP is going to get very confused and very upset. Also, the default configuration from Gigabyte wasn't stable, so I wouldn't even count that as like, oh, that was a good score, because like it couldn't run arbitrary workloads. Sure, the score was good, but the system wouldn't actually be usable in like, you know, day-to-day usage because like Cinebench R15 is very old and not very heavy in the grand scheme of multi-core workloads. So not being able to run it, kind of a major failure. So anyway, we've now like satisfied CEP's voltage requirements, and now we're going to do something about the idle voltages. And to do that, we just enable TVB settings here. And this will actually slightly increase the performance again because the boost algorithm actually benefits from TVB being turned on. But we're still going to see a kind of kind of high voltage for Cinebench under load. But idle is now going to look good. Or, well, it's going to look better. I like, depends on if you think 1.4 something volts is good. So we are back in the OS, and as you can see, at idle, our core voltage, yeah, now we're going like 1.2, 1.3. Even if I don't touch the mouse, we should see 0.7. Yeah, you can see 0.7 there, and I should be looking at, wait. Yeah, I should be looking at this. You know what? I should just collapse these because they get in the way. Because this is the core voltage reading from the actual voltage regulator. Though actually, this Gigabyte motherboard does have an op amp to copy the voltage regulator reading over to the Super I/O, but the Super I/O voltage sensor isn't very precise. I'm not sure what the resolution on this one is, but it tends to be like somewhere between like 6 and 12 millivolts a lot of the time, which isn't great. Whereas this has an accuracy of, I think, 2 or actually this one might be even 1 millivolt of accuracy. So, yeah, this is just a better voltage reading. Anyway, so now we're going to run R23, and I'm going to run it single core, right? Because as you've seen in my past videos, single core load, and actually earlier here, single core load is where we always get the highest voltages, right? Like Cinebench, one core, and then you move the mouse around, and that's how you get your highest V-core. And as you can see, we're no longer going over 1.5 volts. So TVB is doing what it's supposed to. And we're not going over 1.5 volts anymore. And we are getting our 6, well, okay, it's like 5.9. So we're getting close to that 6 gigahertz boost, but we're not quite reaching it. Because I guess the CPU just thinks it's too warm. Probably too warm. Something like that. But yeah, so our like low load voltage, and we've gone all the way up to 1.483, and unfortunately the only way of getting rid of this is to ditch the single core boost, but we're going to look into that later. Anyway, so now I've fixed the idle, but there's one thing that's still kind of not ideal in my opinion, which is that if we run all core, you will notice that, our voltage hits 1.26. And then, oh, it actually just sits there right now. Well, that's annoying. Oh, wait, no, it just bumped up to 1.3. So, there's this kind of dumb behavior on 14th gen CPUs caused by the fact that the E cores and the P cores use the same power delivery. So the E cores, so E cores and P cores share the V core power. Like they both get all of their power from V core. So there's one voltage regulator for both E cores and the P cores. And this leads to an issue where basically the E cores for 4.4 gigahertz have a significantly higher VID than the P cores do for the 5.2 that they run at in Cinebench. Or 5.3 even. Right, because so like the E core, like the P cores right now are throttling down because we're hitting the like maximum voltage, but the E cores will occasionally bring the core voltage up, because of the frequency that they're trying to run at. Actually, I wonder if we could even see the vid behavior of the E cores while it's running. Okay, well, it's just doing all the cores at the same time, unfortunately. No, they're actually dipping to 4.2. Admittedly, I tested this like at night, so I guess we might be seeing more thermal throttling than I had at like 4 a.m. in the morning. But anyway, I should be able to get this score up by actually underclocking the E cores. Because that'll reduce the vid requests. Now, how significant this like E-core vid effect can be really depends on the CPU. On some CPUs, it's really bad. On other CPUs, it's less bad. Because like some CPUs will have awful E-cores that have like insanely high vid requirements, and other CPUs will have good E-cores that don't need so much vid. And it also depends on like how much your P-cores are trying to thermal throttle, or like if you're I guess actually one way I could show this is if I set 52 on all the P-cores, we're not actually going to get a very low load voltage because the E-cores are going to be bringing it up. Because I ideally wanted to show because the way the vid limiting from the E-cores looks is you basically get the voltage bouncing between like 1.26 and then 1.3 volts. But how much you see that actually depends on how much cooling you have and stuff, so yeah. It's really obvious, though, if you try to manually underclock the P-cores to, like, reduce your operating voltages, because what'll happen, and that's actually how, because I actually worked on with did some of this investigation with somebody else, and basically, he had the idea to, like, drop the all-core ratios to, like, 5.4, and the the core voltage didn't get lower when he did that. And the reason it wasn't getting lower is because 5.4 gigahertz on the P-cores was already lower voltage requirements than the E-core voltage requirements at that point. And so he was just hitting the vid limit of the E-cores. So in all-core loads, your E-cores are potentially going to be smashing extra voltage into the P-cores because they share a voltage regulator. So there's really nothing, like the only thing you can really do to reduce, if the E-core, the E-cores basically need to throttle back their frequency in line with the P-cores, which they don't, because the E-cores will not typically, they tend to run a bit cooler than the P-cores do for any given voltage. So, yeah, they don't tend to do that. But if we run at 5.2, is it just not going to do it now? Oh, why are they dropping to 4.2? I mean, the score's the same. Oh, there you go. Yeah, so you just saw that 1.3. Can I get that to happen again somehow? Oh, we're actually losing frequency on the P cores. I mean, the room is quite warm, but anyway. So I'm going to bring the P cores back to auto, and then we're just going to lower the E cores a bit. Unfortunately, I'm not getting the effect to show up as much as it sometimes does, but like, if you're trying to limit the all-core voltages, the E-cores will potentially get in the way of doing that. That is something to watch out for, because the E-cores have just insanely high voltage requirements for all-core load. And the good news about dropping the E-core ratio from like 44 to 42 is that the E-cores, even if there's 16 of them, they actually contribute less, like slightly less than half of the overall CPU performance. So it really doesn't matter very much if you underclock them by 5%, because it doesn't affect the overall performance of the CPU that much. I'm really not sure why Intel is so hell-bent on pushing them so high without having like a separate power delivery system for them. And yeah, you can kind of see how we're like maintaining, well, it eventually drops down to 5.2 again. But we're losing less boost on the P cores now. And yeah, the score just didn't change. Wait, where's my VRV out? There it is. Actually, maybe we'll get even lower voltages than what I was getting yesterday. Oh, wait, no. So, yeah, we get like 1.26, 1.28. Oh, 1.216. So, yeah. You can sort of, like, slightly reduce the all-core voltages by just reducing the E-core ratio, because the E-cores will typically not hit the thermal limit when the P-cores do. And so when the P-cores try to lower the operating voltage, they can't as much as they would like to. So, yeah, and I guess like technically the score went up a little, but that doesn't really, like that's not a not a much of an improvement there. So yeah, that's potentially something you might want to consider doing. Probably the least impactful in well, actually not even the least impactful in terms of performance impact, but anyway. Next thing we're going to do is we're going to turn on ICC Max. Or actually, no, we're not going to do ICC Max yet. Now, I did mention that, you know, if you're not comfortable with the idle voltages going over 1.4, there is something you can do about that. And on a 14900K, that is basically removing the highest frequency bin. So you see how we have two cores that can go to 6? Yeah. Well, no longer. Funnily enough, this really doesn't affect performance as much as you might think. Which means you didn't think about it very hard, because if you pull up a calculator, and you consider like 6 gigahertz divided by 5.7 gigahertz, yeah, 6 gigahertz is only like 5% more performance than 5.7. And of course, that you're only getting that 6 gigahertz at very low loads, right? So if you have like a 4-threaded application, you're not going to have any cores running at 6 gigahertz because if you look at how this works, if there are 3 P cores active, the CPU is already going to clock down to 5.7. So, not really much of a performance loss. I guess what you could do if you want to retain more of the single core boost is instead of setting everything to 5.7, you could have your you could have your 1 core and 2 core limit at like 58 or 59. And that'll still give you a slight voltage reduction. But it won't be as much of a voltage reduction if you just limit the all core to 5.7. With all cores limited to 5.7, like what I've just done, it'll actually drop the idle voltages below 1.4 volts. Even like single core load voltages will be below 1.4 volts. Because like previously we were, maxing out at like 1.48. And yeah, now we're at like 1.338, 1.342. If I run single core, I think we might max out at like 1.36, 1.37. Actually, we're not even getting there. So, yeah, if you're concerned about the idle voltages, like on a 14, like I think actually for any CPU, it's basically just give up your highest boost bins. I don't know how it would look on a 14700K or something, but I would imagine it would look the same. So you saw how like in my BIOS it was like 60, 60, 50, and then everything else was 57. I would assume if you have a 14700K, it would look like what I don't even remember what the spec of a 14700K is. I don't usually concern myself with Intel stock configurations because for decades, Intel stock actually worked, instead of this. But anyway, so if you had a 14700K, your max boost is 5.7 and your all core is 5.5. So I guess your BIOS would be like 5.7, 5.6, 5.6, and then everything else would be 5.5. So I guess you would be I'm not sure that 5.5 would give you much of a voltage reduction compared to 5.6, so you might actually want to be dropping the 14700K to like 5.4 for your idle voltages, but you can try 5.5, and if you don't like what it does, you can go to 5.4. Anyway, oops, wrong scene. Yeah, so... and we did eventually get up to 1.64. So yeah, by basically ditching the 6 gigahertz boost, the idle, like the low load and idle voltages go, they get like very sensible instead of the thing is like Intel's been shipping these Intel 7 nanometer, like Intel 7 manufacturing process CPUs with like idle voltages of above 1.4 volts since 12th gen. Like I'm pretty sure 12900Ks run above 1.4 at idle. So I find it a bit strange that like 1.4 on 14th gen would be unsafe if it was safe on 12th gen. But then again, like, because you would assume that if they're improving the manufacturing process, the reliability of the manufacturing process gets better, not just the frequency. Though I guess that's not necessarily impossible, that like whatever optimizations they did to get the frequencies up might have actually made the architecture more susceptible to high voltage or something. I don't know. Testing for I don't have Intel's reliability data. And at this point, honestly, I'm kind of questioning if Intel's reliability data is even any good, considering that they still don't seem to have a answer for like what's actually going on, other than like, yeah, well, motherboard vendors aren't turning on protections, which is not much of a answer, in my opinion. But anyway, so yeah, if you're concerned about the idle voltages that much, you can drop the all P-core ratio to 5.7. If you're lowering the P-core ratio even more than that, then again, the E-cores might get in the way. And the E-cores will actually get in the way of all core loads, even without reducing the P-core ratios like this. So I would say probably on most CPUs. Well, it depends how bad your E-cores are, I guess. But I think it's probably worth it to lower the E-core frequency by 100 or 200 megahertz, depending on what kind of voltages you're getting, and you might get slightly better voltages by doing that. And by better, I mean slightly lower, without relying on, an undervolt like the default BIOS configuration does, which you can't do because you have CEP turned on. So anyway, the last thing we're going to take a look at is ICC Max. Which is under turbo power limits. We're going to enable those. Now, I don't really think that the power limits in and of themselves should really be much of a concern. And I think, like, from Intel's statement, it really kind of looks like they don't think they're also don't really think they're a concern, right? Because they have additional settings which may increase the risk of system instability, increasing PL1 and PL2 beyond Intel recommended limits. They're not listing these. I mean, I guess they are part of the list of the, like, various safeties, but there's, like, a extra bullet point in front of that to me kind of indicates, because it doesn't really make sense that like Intel's been okay with motherboard vendors maxing out the power limits since freaking Haswell. And yeah, so I think the like ICC Max is probably a bigger concern than the power limit being set to whatever. Also, if you use, depending on which ICC Max you use, the ICC Max actually, you're going to hit ICC Max way before you're going to hit most power limits. Because the way ICC Max works, and let me just... yeah, so... Are we going to read through this? Now we're not. I'm just going to summarize how like ICC Max is measured. So ICC Max is actually measured by the CPU itself. And again, it's measured similar to how CEP functions. So the CPU measures the internal voltage drop inside itself. And this means that basically the CPU is monitoring the current flowing. So if you look at your like current monitoring in, say, hardware info, right, and you have a motherboard like this one, which exposes the voltage regulator power, current readings and stuff, you'll have an I out reading. And what you'll notice if you set a low ICC Max, and I keep switching to the wrong scene, let me just shuffle things around a bit. Anyway, so we're going to, like right now what we're going to do is we're going to actually use the 307 amp ICC Max here, and you're going to see that this basically acts like a 250 watt power limit-ish. And there's a reason for that. And the reason for that is that ICC Max is based on the current flowing through the CPU, not the current flowing through the voltage regulator. Now, you might be very confused about how can you have current flowing through the CPU that isn't flowing through the voltage regulator. And what's going on with that is that you have like the average current that the CPU is pulling, that flows through the inductors and the power stages of the voltage regulator, so the voltage regulator can actually see that. It can measure it. But then there's a bunch of current that actually flows through the decoupling capacitors on the motherboard and on the CPU, right? If you look at the back of an Intel CPU, there's a bunch of little multi-layer ceramic capacitors on it. You have a bunch of multi-layer ceramic capacitors inside the CPU socket. There's a bunch of multi-layer ceramic capacitors on the back of the CPU socket. And then you have your polymer capacitors, go like around the CPU socket. And there's a bunch of current flowing through all of those capacitors as the CPU runs. And the voltage regulator can't measure this. The CPU can, because all of that current that's flowing through those capacitors also goes through the CPU. So that's why you hit ICC Max way before you see that amount of current draw on the actual voltage regulator, because it's literally like ICC Max accounts for current that even the voltage regulator isn't outputting, right? It's just current that's flowing in and out of the output filtering capacitors. So anyway, we're going to start with the 307 amp ICC Max, because I do actually have enough cooling that we're going to hit the power limit before we hit the thermal limit with 400 amp ICC Max. I mean, we're not, 400 amp we wouldn't hit that, but 307 we will. And this is probably going to hurt performance kind of a lot, maybe. Well, yeah, it's kind of going to hurt performance a bit. Did I enable 6 gigahertz again? Oh, I didn't. Yeah, but you can see now we're hitting like 5.1 instead of 5.2. And you'll see the temperatures are actually very good because the CPU is hitting the power limit at 260 watts. And actually, I'm not sure how accurate that is because of the DC load line settings. So instead, we're going to take a look at our power output and we can see 250. Right? And yeah, we're getting like 38,000 points. So now we're really starting to lose performance. So yeah, you can see that we're pulling like 250 watts and only like 200 amps coming out of the voltage regulator. And it's like, but how is the CPU like throttling itself when, 200 amps is only coming out of the voltage regulator? Because there's like another 100 amps. It might not be literally 100 amps flowing through the capacitors, but that's sort of the idea behind this. Is like there is current flowing through the capacitors that, the voltage regulator just simply does not see, but the CPU does. And that's what the ICC Max actually keeps track of. And so, that's what's going on with ICC Max. And of course, ICC Max on most motherboards by default is, where we're going to go back to the Intel statement. A lot of high-end motherboards simply enable the ICC Max Unlimited bit. Basically, the ICC Max Unlimited bit tells the CPU to not worry about how much current is flowing through it. If 13th gen and 14th gen have issues with electromigration, yeah, turning that off is probably not the best. Along with CEP, right? So, anyway, so now we have ICC Max turned on again, and as you saw, that kind of, hurt performance quite a bit. But there is the 400 amp spec from Intel. Now, this is the thing: is like, do you trust Intel? And are you willing to run the 400 amp ICC Max? It's not like, well, I guess it depends how much cooling you have. I obviously don't really have like quite enough cooling here. So if we set the ICC Max to 400, we will end up thermal throttling, whereas at 307, I don't. Though, again, in the Intel documentation, like, it really seems like 400 amps is the highest number I've seen in the 13th, 14th gen documentation. And wait, no, this is the 14th gen doc. Oh, yeah, it says right there, 14th gen. I also have like the 13th gen one, so I was a bit worried that I only had there's an old version of this document that only applies to 13th gen. Anyway, but you'll notice that we have like a 400 amp, 320 amp, 245, 307. But yeah, there's nothing higher than 400 amps anywhere. We also have like for 125 watt CPUs a 400 amp ICC Max option here, right? So it's not just 150. So I think Intel seems to, like, to me, this shows that like Intel thinks that 400 amps is the absolute highest ICC Max you should ever use, and anything below that should be fine, probably. So, you might want to, so potentially what you could do is, tune the ICC Max to match your cooling capabilities if you don't really trust the thermal limit. But if you do trust Intel, then running 400 amp ICC Max should be safe, according to Intel's own documentation. So, yeah, especially if you have CEP turned on, ICC Max turned on. There's not really any way to set... well, actually, no. Asus motherboards, you can have the ICC Max limit disabled at the same time as actually punching an ICC Max number into the BIOS. Gigabyte boards don't let you do that because Gigabyte boards don't give you access to the unlimited ICC Max bit directly. Yeah, so anyway, here we are back in Windows, and now if we run Cinebench, I think we're probably just gonna, well, we should get back up to 39,000 points, and it'll thermal throttle again. Yeah, it's still thermal throttling. It might be slightly less. And you can see we're pulling about 320 watts. I think we did peak at 352. So yeah, 400 amp ICC Max ends up with behaving as a sort of like 300-ish watt power limit. Oh, actually, we didn't peak at 300. Yeah, okay. My DC load line is off, so the power limit reading is off. The VRM only saw like 317. I guess that might be kind of close, because technically the CPU package power also accounts for things like system agent power draw, memory, well, no, system agent, not memory. Memory shouldn't be part of it. But yeah, like system agent, what else? Well, iGPU, but the iGPU isn't doing anything right now. Ring is part of vCore, so we actually, like, ring power consumption is reflected in this reading right here. So I guess mainly just system agent would be the thing that, like, gets added with the CPU package power draw. But yeah, at 400 amp ICC Max, you can see the score has gone back up again. So yeah, and if I had more cooling, this would actually probably score, like, it would score even better, because we are thermal throttling. Or if you had a better CPU, actually, if you have better, like, silicon quality, you're going to get better frequencies with this configuration than I'm getting. Anyway, so that's 400 amp ICC Max. And that's kind of everything I wanted to show. So basically, this is like my idea is, like, you want IACEP enabled, because the thing is, my experience with IACEP being enabled is once it's turned on, it becomes borderline impossible to get the CPU to crash. Like, I could say, do this, right? And just... and without CEP, what I just did would be completely unstable. Actually, we might not be able to get into Windows. I'm not entirely sure why the motherboard just power cycled. But I think with CEP we should still be able to run things with a 300. Oh, apparently that completely failed. Well, I did not expect that. Oh. What? It doesn't let me... Oh, man, I need to... Yeah, so the one downside to having CEP turned on is it just completely breaks undervolting. By that, I don't mean the whole, like, oh, it didn't work at minus 300. I don't know why it didn't work at minus 300, but if I set, like, minus 100, we're going to be back to that situation we were at with, like, Gigabyte's default VRM configuration and CEP being turned on, where it just destroys performance. But it doesn't crash. So if your priority is stability and you're not, you know, undervolting your CPU, like, CEP is a good idea. And in fact, this whole, like, configuration that I've shown here with, like, very low V-droop, and then just, like, CEP turned on, TVB turned on, right? Like, my idea behind this is, like, this is kind of similar to how NVIDIA GPUs do their power delivery, where they have very little V-droop, and then to make sure that this GPU actually manages to function correctly, the GPU just clock stretches anytime the voltage is too low for it to function. So, yeah, and evidently Intel CPUs seem to be capable of doing the same thing if you configure them correctly. I mean, I'm not sure if this is, like, correct, but... Oh, no, CEP is definitely kicking in. Yeah, you can see the power draw is really low. I mean, you can also see it here with better accuracy. So yeah, the CPU is, like, clock stretching like crazy because the current excursion protection mechanism is like, why is the voltage so low? What's going on? And so the performance is going to be back to being completely terrible. And that also happens if you just turn on CEP with the default motherboard configuration. Yeah, which is why motherboards default to having it disabled. And depending on like the thing is, like the CEP stands for current excursion protection, but I don't know how much protection it actually offers. Like that's the one issue is like, so it could be that like turning off CEP is actually very bad for CPU longevity on stock configuration. Or it's not relevant to the current situation at all. I mean, I think to the stability side of things it is, because as you can see, once you turn it on, I don't know how you would get the CPU to crash at this point. As long as you what CEP won't help with is if you try to overclock the CPU. So if like I wanted to run 6 gigahertz all core, yeah, CEP won't really help with that kind of setup. But for this kind of situation where it's like I'm actually still within the like stock vid table of the CPU, like in this configuration, like CEP, I'm not sure it's possible for the CPU to crash. Now, if I was like trying to set the CPU ratio, man, even the BIOS is clock stretching. It's so slow. But like if I wanted to set 6.1 on the cores, like CEP doesn't deal with that, in my experience. Or if you like wanted to set 8P core active to like 5.8, CEP probably won't be able to deal with that either. But if you just want to use like the stock frequency configuration from Intel, CEP makes it basically impossible to get the CPU to crash. Yeah, and it's not going to destroy your performance unless you're like trying to undervolt the CPU and breaking the CEP functionality, right? So yeah, now then, so with ICC Max, depending on how much you trust Intel, you can set like 400 amps or less, right? Some numbers that Intel suggests are like earlier I mentioned 400 amps, 320 amps, 307. If you want your CPU to be very, very slow, you can set to 245. I would not recommend that. That'll take your i9, and this will turn your i9 into an i7, basically. Because this acts like a roughly 180 watt power limit. So yeah, would not recommend that. 307 probably the best option to not have the well, okay, 400 amps, I think you'll basically not see ICC Max throttling at all, and you're probably just mostly going to see thermal throttling. 307 is probably like the happy middle ground. But yeah, like the thing is, I don't know for sure, because there's rumors of degradation, right? And like, it does seem that, you know, CEP and ICC Max should have per core current limiting capabilities to some extent, maybe. I imagine they would also have like ring current limiting capabilities. So it could be that CPUs are degrading because motherboards want to run undervolts, so they have to disable CEP. So then your CPU is like, it's technically undervolted, but there's no current limit. And then I actually don't know why they disable ICC Max out of the box at all. I just don't understand that. But they do. And so it's like, it's possible that like the degradation is caused because the CPU has like very brief, you know, current spikes that are just insanely high. Or you have like very high current draw even on like one core loads, or just, you know, like in like low load scenarios, because the default motherboard configuration, at least for all core load, tends to actually run less voltage than any configuration you can run once you turn on CEP, right? Because CEP, like, it requires a minimum voltage to function. That's why it gets turned off, is because motherboard vendors are undervolting the CPUs, and that's why you also get you can buy a brand new factory sealed 14th gen CPU, stick it in your motherboard, and not be able to run Cinebench 15, or not finish shader compilation, or get like out of video memory errors, right? That happens with brand new CPUs because the CPU is getting undervolted right out of the box. Now, if you have a CPU that's been running for 6 months and it used to be okay and now it's not, well, that might be because it never had a current limit. Maybe. I'm not 100% certain if that's why that happens, but that would be a potential cause, is that, well, the CPU didn't have a current limit, so, it's like excess current draw protection. Yeah, that's turned off. ICC Max also turned off. And these are both like current limiting functionality that are actually CPU side instead of, motherboard power delivery side. So they should be able to do much more precise current limiting than like a VRM current limit, which Intel doesn't even really seem to concern themselves with. Well, they do, because obviously if your motherboard can't supply 400 amps to this, like if your motherboard can't supply the CPU with, like there's a spec for how much power your VRM has to be able to, well, that's not has to be, but like there are specs for like you have the iTrip current, which is like the current limit of the VRM itself, which for most high-end motherboards on the Z790 is sky high because, actually, I'm not even sure what it is on most boards, because your voltage regulator is typically going to be like 12 plus 60 amp power stages. So, a 500 amp current limit on the motherboard side is a perfectly sensible thing to do. Because you have like 12 60 amp power stages. And in fact, like depending on the motherboard vendor, you might even have like a 720 amp current limit. But anyway, from like the VRM side, right? But the ICC Max, like that's always been enforced from the CPU side. So yeah. Anyway, yeah. So that's kind of like my idea for trying to fix the instability and like getting the operating voltages down is like turn on CEP, turn on the TVB. Like if you're on a gigabyte motherboard, it's basically turn on this. Also, I need this clock stretching to go away. This is so annoying. Like navigating the BIOS with the CPU like running at like 3 gigahertz, not fun. Actually, I'm not even sure if it's a clean 3 gigahertz. The clock stretching might be causing some very strange behavior. Anyway, so there we are. Yeah, now the BIOS is much more responsive. Okay. Anyway, so yeah, enhanced TVB on, voltage reduction initiated TVB on. This brings the idle voltages down. IACEP on, GTCEP on. What else do we have? Right, for the, like, if you're concerned about your idle voltages, you can drop your active turbo ratios from, like, this configuration down to, like, whatever your 3-core ratio is, or, like, 8-core ratio is. I think this is going to look very similar. Like, I'm assuming a 14700K is just going to be 56, 56, and then 55 for the rest of them. So, but you can, like, lower your turbo ratio. If you're going to be lowering your turbo ratio, keep in mind that the E-cores can potentially have a higher vid than the P-core vid. So especially if you're at like 5.4 or something, the P-core vid can get very low, whereas the E-cores for 4.4 or 4.3 gigahertz, they will often need a lot of voltage. So, yeah, you might want to drop them down like 100 or 200 megahertz to, that'll help like all core loads, but also even low loads, you might see slightly lower voltages with the E-cores not being able to turbo as high. And yeah, so that's something to do. And then for the power limits, I mean, I wouldn't really concern myself with the power limits in and of themselves, but the ICC Max, if you trust Intel, you can set 400, you can punch in 400, and that'll basically act like a 320 amp, 300 something watt power limit. And if you don't trust Intel that much, you could set it to like 350, 300, 250. At 250, your CPU is going to get very, very slow for multi-core loads, but yeah. Personally, I think if I was dailying a 14th gen, I would probably go with... well, it depends how much cooling I had. If I had a custom loop, and I wasn't hitting 100 degrees in all core loads, I would actually probably just stick to the 400 amp current limit. With an AIO, I guess 300. Well, you can tune it a bit. Depends how much you care about your multi-core performance. Like, I daily a 7800X3D, so evidently I don't really care that much about, getting 40,000 points in Cinebench, because the 7800X3D does not get 40,000 points in Cinebench. I'm pretty sure it gets less than 20,000 points, right? So, like, I'm perfectly happy with my daily system having less than half the multi-threaded performance of a 14900K. So if I did daily a 14900K, I don't really think I'd have much of a problem with running a current limit of like 300 amps or something, where it like shaves off, it drops Cinebench from like 39,000 points to like 38,000 points. But yeah, though if I had like plenty of cooling, I guess I would just stick to the 400 amp ICC Max. So this is the I this is the value where it's like you can play with this one. I would not set it above 400. Right? Considering that Intel doesn't seem to recommend, Intel doesn't really seem to care about the power limits, but they do seem to care about the ICC Max, which makes sense because the ICC Max is the ICC Max throttling kicks in way faster than the power limit does. So it makes sense to me that would be like, from a reliability perspective, that would be more important than the power limits would be, especially considering that like historically Intel has never really cared about the power limits. Anyway, and then for the CPU settings, I mean, if you're on a Gigabyte motherboard for extreme load line calibration, IAC at 12. Actually, even 10 can work, which will give you slightly lower voltages. But the thing is, like, once you have CEP turned on, if you set your AC load line too low, you're obviously going to have some major, like, performance loss. So this is a value that, like, the thing is, CEP actually varies how soon it kicks in for a CPU, because some CPUs have somewhat more undervoltage headroom relative to CEP than others. So you might find that, like, with extreme LLC on a Gigabyte motherboard, your CPU might actually need an AC load line of 15 for CEP to not complain about it. I only have one CPU, and even on 10, mine actually works fine. Okay, not 15, 10. But yeah, even with like 10 AC load line, my CPU actually like works okay with that. But I did try 7, and at 7, it starts losing a lot of performance. So this is, like, if you set it a bit high, you obviously get a little bit more voltage. If you set it a bit low, well, you get a bunch of clock stretching with CEP turned on. Without CEP turned on, you get crashing. Yay! So yeah, you might want to play with this, but if you want to err on the, like, if you want to configure this less, you probably just want to set it to 12. And then I'm pretty sure my DC load line right now is maybe a bit too low, because the power readings, like, I unfortunately don't know what exactly the, like, Gigabyte Extreme LLC translates to in terms of a load line slope. Because basically the idea with DCLL is you want to match it to the VRM load line slope so that the power readings are accurate. But that's only really a concern if you actually want to use the power limits, right? And speaking of power limits, oh, I guess it's under thermal management. Processor. Yeah, so, like, on the power limits front, like, Intel suggests 253 watts, which if you have the ICC Max of 400 amps, yeah, you're going to hit slam straight into that. If you have the ICC Max of 400 amps with the 320 watt power limit, you're not really going to hit that. Also, I do not understand why the 150 watt CPU would be able to handle more current, like more power, than the 125 watt CPUs when they have the same number of P cores and E cores. Because I kind of doubt that Intel is binning the silicon for higher reliability, right? Which is what this would imply. Is like, oh, the silicon that goes into a 14900KS is better able to handle 320 watts in terms of reliability than the silicon that goes into a 14900K. Like the Silicon Lottery does affect CPU reliability, but I kind of doubt that Intel would be making those kinds of binning decisions with their 14th gen CPUs. That seems kind of weird, especially when like they've been advising at least their motherboard manufacturers that yeah, you can just run whatever power limit you feel like, and usually that translates into no power limit. So I think this is more a configuration that they're suggesting to like OEMs like Dell, HP, and that kind of thing, where they actually need to design a cooling system for it. Um, so yeah. Anyway, let's check if I've gotten the power readings to be a bit more in line. Um, and I did turn the 6 gigahertz boost. Yeah, we have the 6 gigahertz boost back on again. Also, with the DC load line, I would recommend not setting it below the AC load line. I don't think it would actually cause anything bad, but the Intel documentation like doesn't really seem to support the idea of a DC load line that is lower than AC. Though I guess that might be because if your AC load line is like 50, then like your power measurements would never be accurate if your DC load line was lower than that. Okay, I think the package power reading is actually it might now it might be a bit high. Score is good though, but I think that's mainly because the cooling system managed to cool down at this point, because we've not really run any heavy load for a while. And yeah, now that the 6 gigahertz boost is back on, the idle voltage goes back up to like 1.47 again. If we run a single core load, yeah, we're at like 1.44 volts, but also our CPU temperatures are like 60 degrees. I'm just going to reset the monitoring so that the maximum temperature, and you can see that, yeah, 66. The per core current draw is like 40 amps. I wish we could see what I guess you could, I guess something to test would be to like intentionally set a very low ICC max to see if like when like one core starts hitting ICC max, but that I guess is gonna like not gonna be super accurate for anything. Yeah, I think my CPU package power reading right now is a bit low. Oh well. Anyway, so that's single core. I am also kind of wondering about like partial load that isn't like all the way down to one core, so we're gonna try, yeah, sure, 4. I imagine 4 core load is just gonna hit the 5.7 and we're gonna be, yeah, at like 1.3 volts, which is a nice, sensible. And yeah, CPU temperatures are actually very decent. So yeah, this is like my idea for like trying to fix the instability of a 14th gen CPU or 13th gen CPU without nuking the performance. It is possible if that your CPU degraded a lot, then like if the CPUs are degrading and you have a very degraded one, because again, like the degradation thing, very hard to like verify. Because like just because your CPU used to work and now it doesn't necessarily mean it degraded. It might have been some kind of software change somewhere. Um, but um, so like one concern is like if you have a degraded CPU at this point, like the settings I'm using here might not be enough to fix the instability. Though I have been kind of wondering about if the CEP functionality can actually sort of like if over time as the CPU degrades, if the CEP starts kicking in more and more. So instead of instability, if your CPU is really degraded, once you turn CEP on, you just end up with performance degradation, which is not great, but arguably better than a system that's literally unusable. And then of course, like if it causes less performance degradation than the Intel baseline profile, I would consider that a win. So, yeah. Also, like this configuration that I'm showing here, as far as I'm concerned, like compared to the, especially the Gigabyte Intel baseline profile, I think this is a better configuration because from what I can see, the performance is higher. The voltages are way lower, especially at idle. Um, and that's kind of that. So, and I have all the Intel protections turned on. And if you're not, if you're concerned, you can always just take the settings I'm using here and run them at like 5.7 all core instead of having the 6 gigahertz boost turned on. If you're on a 900K, if you're on like a 4700K, like 700K, then obviously you would be going from 5.6 boost to like 5.4 all core probably. Maybe 5.5. I don't know how the voltage table behaves on the 14700K. And then also the ICC Max, like, you could set, like, I really wouldn't be setting it to 245 because at that point you're basically going to get the Intel baseline experience in terms of performance. I mean, I guess I can show that. Actually, it shouldn't be. The funny thing is, because Gigabyte's Intel baseline profile sets such insanely high voltages, we're probably actually going to see less of a performance degradation with the 245 than with Gigabyte's baseline settings. Because, yeah, I don't like the Gigabyte baseline settings seem like they honestly seem to me like a way to get out of replacing broken CPUs. Because, like, I don't understand why they raise the voltage so much, unless the idea behind the baseline profile is like, look, if you have a CPU that's like degraded to the point of being basically non-functional, well, if we apply 1.6 volts to it, it'll still run. For how long, I don't know. Oh, wait, we're on 4-core load. Yeah, so now we're dropping like way below 5 gigahertz. Temps are great though. The CPU's hitting like yeah, we're pulling like 180 watts and 160 amps. So yeah, the ICC Max, like it really does monitor a bunch of current that just doesn't go through the voltage regulator. And we're at 34,000 points. Yeah, so this is basically the Intel baseline profile experience in the 245 amp limit. So, and actually, I think if we go back to the Intel documentation, yeah, so if you check this, right, we have ICC Max is the maximum current the processor can draw, typically seen running a virus application. This current is used to design the voltage regulator decoupling, right? So by that they mean the capacitors of the motherboard. And so you can see, like, yeah, ICC Max actually monitors the current flowing also through the decoupling capacitors. And then ICC Max.app is less than ICC Max and is the electrical current drawn by the SoC while running a typical user application scenario. It corresponds to Pmax.app. So basically, what I was trying to get at with that is that if we go to the ICC Max settings, you'll notice that the 245 is the app limit, whereas this is the like absolute limit. So I guess you could also go with the 320 amp app limit that the like 150, though. I think that's also, yeah, we also have that for the 125 watt 16E core CPUs. So yeah, I don't think this is a actual, because like this is supposed to account for the current flowing through both the supposed to account for the current flowing through both the voltage regulator and the output filtering capacitors, whereas this is, it's still going to factor it. Like, this is not really supposed to take the, like, capacitor current into account. So it really doesn't make sense to me to use this as a current limit. Because this, I think, is supposed to be, like, the average current seen by the voltage regulator rather than the current seen by the CPU. Like, all current seen by the CPU. Right? Because that's what the whole point of ICC Max is. So I don't know why you'd have like two different ICC Max values like that, unless one of them is supposed to be for something else. So yeah, that's kind of my thoughts on like how I would try to fix the instability. Is basically what I've just shown here, where you turn on the CEP, you turn on TVB, you set a very shallow load line and then adjust the AC and DCLL to match. Because technically you can try to tune CEP to work with like auto LLC. And actually we can quickly check what that does. So I'm going to assume that Gigabyte's DC, like stock DCLL is correct for what the ACLL is needs to be. And I think with TVB turned on, our idle voltages might still be okay. But I'm not 100% certain. Oh, I forgot to turn off the ICC Max. I mean, set the ICC Max to 400. Though I'm pretty sure Gigabyte... Wait, I guess the Gigabyte's Intel baseline profile might not have turned on the TVB optimizations. I guess we'll find out right now. Well, we've already hit 1.47, but that's not really that high. I want single core. Nah, seems pretty sensible in terms of voltages. So I'm really confused why motherboard vendors don't have TVB turned on by default. I guess it would mess up their, like, questionable undervolts. Well, actually, Asus does have TVB on by default. So they're just like, I guess, confused why Gigabyte doesn't bother with it. Did I not? No, we have 6 gigahertz boost. Why is it not hitting it, like, at all? Okay, I'm gonna... What? No, set it to freaking 12. Alright, that's the... because that's the boost core. Or at least it should be the boost core. Yeah. Okay, so as long as you turn on TVB, the voltages will actually be sensible. And if we just run all core... Oh, wait, I have the affinity set. Apparently that doesn't matter? Yeah, scoring a bit worse. Just gonna rerun it again. I mean, the water temperature might have gone up at this point, but... Okay, this definitely seems to be boosting less than my, like, flat LLC configuration. But this also works, so... Wait, what? When did that happen? Why? So the one thing I'm, like, still wondering about with my, like, extreme LLC and then, like, super low AC/DC load lines to match is what it looks like on the oscilloscope. Because the thing is, like, anything you see in hardware info, I mean, this... I don't know that this could be a sensor error. It's not impossible. The thing is, like, usually when you have bugged out sensors, it reads out some, like, you know, it hits, like, the bit limit of whatever the sensor is. 1.592 is not, like, a reading limit. So that might be real. And the thing is, if hardware info measured something like this, that voltage had to be applied to the CPU for a relatively long amount of time. That's not a transient spike. Oh, wait. Move it. What? Oh. Oh. Okay, wait. We're going to check what happens with my, like, no V-droop setup. My NVIDIA style setup. Because that's, like, really, that was my inspiration, is, like, NVIDIA has, like, no V-droop on their GPUs, and they just use clock stretching to deal with all the instability. And so, you know, Intel CEP is like, well, it's not... I'm not sure if that is its intended purpose, to be, like, a clock stretch over any kind of instability issue. But it certainly seems to do that. So... So I don't really see a so if it does that, I don't really see a problem with, like, oh, just, you know, turn CEP on and then flatline the load line calibration. Because any undershoot, CEP is going to deal with it, as far as I can tell. That's, like, the main thing I've been wondering about, and I'd like to get, like, community feedback on, is if you try this configuration of, like, very flat load line with CEP turned on, do you have instability? Because my experience with CEP is, like, once it's on, like, you can't crash. You can lose performance, but you can't really get it to crash anymore. So that's kind of the thing that I'm wondering about, is, like, well, you know, this solves the crashing. The voltages are sensible. Okay, I think 1212 might have actually been the correct setting from the get-go. In terms of, like, getting the power readings in line. Though I don't have a power limit, so I don't know why I care about that. The nice thing about ICC Max is you don't have to worry, like, it literally just uses the voltage drop across, like, internal to the CPU, so you don't have to worry about the DC load line being incorrect to have ICC Max working correctly. At least as far as I can tell, like, ICC Max is not affected by DC load line settings or AC load line settings. So yeah, apparently dragging the Cinebench window around with like VDroop turned up causes some very high voltages. So we're gonna see if that happens again, and hopefully Windows isn't gonna do the thing where it minimizes all of my windows. I don't know why anybody thought that was a good feature to have. I am dragging the Cinebench window. I am not seeing any crazy voltages. That. And we're not on the boost cores again. Right, no, it is on a boost core. How is the... Oh, it's not boosting that hard. Oh, no, yeah, it's like switching off of it when I move the mouse around, because, like, the scheduler is trying to figure out, like, what I'm, like, most interested in right now. Can I get my 6 gigahertz boost, please? So, yeah, honestly... Well, the voltages are fine. So yeah, I guess this like flat load line setup just like it doesn't have the same insane voltage behavior that you get when you have VDroop, which is weird, but like if the voltage measurement is showing up in hardware info, it has to be applied to the CPU for like multiple milliseconds at a minimum. Because the sampling interval for hardware info is 500 milliseconds right now. So, like, it's not going to pick up very short spikes. Okay, now if I drag the window around, we are getting some, like, 1.47, but we're not seeing that 1.5 that we got last time in the maximums. So, yeah, I guess this setup is actually pretty sensible. Also, you can see that the score's gone back up compared to using the VDroop configuration. Yeah, so this is like the thing is, nothing I can see in the Intel documentation makes me think that what I'm doing here is a terrible idea. That might be because I'm an idiot, right? But compared to especially the Gigabyte Intel baseline profile, this uses less voltage. It's stable. It's faster. If you're concerned about the temperatures, you can just change the ICC Max until your cooling system keeps up. I see I'm not seeing any real downsides to this way of like setting up the CPU. Except maybe that the thing is I can't really do I mean I guess I could, but I don't really want to do like exhaustive stability testing. I've not been able to get this to crash. I've like run Prime 95 on it. I've run Y-Cruncher on it. Admittedly not for very long, but like I haven't yet had a situation where like this CPU, once I turn on CEP, like I haven't had a situation where it crashes. Right? Whereas on the Gigabyte default settings, yeah, it crashes all the damn time. So, especially in Cinebench 15, which with this configuration, is completely fine. It even runs at like 5.4 gigahertz because it doesn't get so hot. That score's a bit low. I think that might be because I was scrolling around. There. So, yeah. So this is like an idea I've had for trying to fix the instability and like get more sensible operating behavior out of the 14th gen CPUs. Like the voltages are lower, the temperatures aren't, because like in order to get low temperatures at high load, the CPU would have to be running at less than 1.2 volts, right? So the only way you're really doing that is if you set a, well, you could set a power limit. You could set the ICC max to like not 400 amps, right? You know, like I think if I set it to 320, then yeah, like on this setup, 320 ICC max would get the temperatures under control, I think. It depends on your cooling system. You could also possibly, like, one thing you might consider is like having a 400 amp ICC max and then just setting a temperature limit. I don't really see a, like you could do that. The thing is, as far as I can tell, the ICC max throttling kicks in way faster than any other throttle. Like ICC max throttling kicks in before everything else does, except maybe CEP, right? Because CEP will literally start clock stretching the CPU before the CPU manages to blue screen. So that has to kick in really, really fast in order to maintain stability, right? Because that literally, like CEP has to kick in before the CPU can make a calculation error. ICC Max might also be as fast as CEP. From my reading, the mechanism, like the way they work, seems to be similar. So they might actually be the same, like reaction time to any kind of overcurrent event. Or in the case of CEP, under voltage event. Yeah. So like, so basically what I'm trying to get at is if you like limit the like if you lower the temperature limit with a high ICC max, like technically the ICC max will well, you'll be losing some performance. I guess we can just take a quick look at that. Is like set the temp limit to 90. And for low core loads, like this configuration that I'm using here is actually, like at least with this CPU, it really seems quite sensible. I don't know how maybe like a 14900 KS would react, because a lot of KSs have very high vid for their 6.2 gigahertz boost, right? Like there are 14900 KSs where the 6.2 gigahertz is well above 1.5 volts. So with those CPUs, I mean, even with the settings that I'm running here, I imagine your idle voltage would be above 1.5 volts, just because that's where the vid table goes. But at that point, it's like, well, Intel set the like Intel at the factory set the 6.2 gigahertz vid at 1.52 volts. So either, or 1.55 volts, or whatever it is, right? And so either Intel doesn't know what they're doing, or the CEP and the ICC Max are very important for processor longevity. Is sort of the way I see it. Because if it turns out that the CPUs are degrading due to voltage alone, then Intel shipping CPUs with a vid of more than 1.5 volts is just like that's just irresponsible from them, because they're shipping out silicon that's not going to last for a. Well, I guess Intel's intention is that it survives the warranty period, but evidently they haven't been very good at making certain of that. Anyway, what was I going to do? Right, set a temperature limit. Obviously, the lower the temperature limit, the less performance you're going to get in temperature-limited scenarios. I think like 92 would probably not be that bad, but let's just go with 90. And this is obviously also going to reduce the operating voltage again, because we're going to hit the thermal limit sooner. So the CPU is going to like throttle down sooner. I guess the thermal limit not being super quick to kick in is part of the reason why you can occasionally see the like temperature on the CPU exceeding 100 degrees, right? Like earlier in this video, we saw it at like 104, even though the temp limit is 100. Actually, and occasionally it pretty regularly ends up at like 101, 102, and that's probably just because the temperature limiting mechanism just isn't that fast compared to, say, like CEP or ICC Max. We're actually getting very, yeah, initially very decent frequencies. It's not really not. I don't think we're going to lose that much performance. We're hitting like 280 watts. And yeah, we lose like 500 points. Max voltage is still less than 1.5 volts. Obviously, that's like idle. When the benchmark's actually running, we're getting like 1.25. Yeah, because 1.2. It's hovering between the two. So yeah, that's like, so I think if you're like paranoid about the degradation side of it, you can also like lower the temp limit a bit. And even 10 degrees, I think, would make a very big difference to the rate of degradation, because temperature makes, like, every aspect of silicon degradation gets significantly worse as temperatures increase. I would not recommend setting a temp limit without setting an ICC max, because I've tested that in the past, and yeah, that does not work. Especially if your CPU is like unstable out of the box. Actually, setting ICC max can often fix some of the instability, maybe all of it even. But if you like just set a temp limit, that will actually not fix the instability, probably because the temperature limit really doesn't kick in that quickly. So the CPU will be able, like, if you're thinking, oh, I'm going to fix my instability by just lowering the temperature limit, yeah, that doesn't work in my experience, because the CPU will crash before it overheats, or like before it hits the temperature limit. And I think in this configuration with like 400 amp ICC max and 90 degree max operating temperature, like especially gaming performance, I don't think would be affected like at all. Because at 400 amp ICC max, like I don't think any game is going to be hitting the ICC max limit, which I've heard that at like 300 amp ICC max, so like the 307, you might actually start seeing games hitting ICC max occasionally. With 400 amps, I don't think that's ever going to happen. But games also don't tend to hit 90, like 100 degrees. So the 90 degree temperature limit won't even kick in like it does for Cinebench. And even when it kicks in for Cinebench here, we're not really losing that much performance. Now, admittedly, if we compare it to the like default settings from Gigabyte, which are unstable, we're down like 1,500, 1,700 points now. But we don't crash. The voltages are lower. And I guess we could pull up a calculator for one last time. Wrong calculator. Yeah, we want the big calculator. Anyway, so I think at the start we got like 40,300 points, or something like that. And that's only like it's not even 5% faster than what we're getting right now. And this is with a 90 degrees Celsius temperature limit. Without the temperature limit, right, we were actually going over 39,000 points. Also, that first run probably was maybe with cooler water temperatures, so it might have been like thermal throttling slightly less. But anyway, so, it's like a single-digit percentage performance reduction compared to the Intel baseline profile, which, like, drops you down to, like, 34,000 points-ish, or, like, it's bad. Especially the Gigabyte one is really bad. And, yeah, so there. Hopefully this is somewhat helpful, with the like instability on 13th gen, 14th gen. I am not going to guarantee that the configuration I'm running here is going to prevent degradation, but because like I don't know, right? Like I'm assuming, because the thing is with this configuration right now, like the vid on my CPU for 6 gigahertz is 1.498 volts, right? So, like, the only way I can get the voltage any lower at this point is if I ditch the 6 gigahertz boost. Right? And I'm going to assume that if Intel put a 6 gigahertz vid of 1.498 volts on their CPU, there is some operating scenario in which that it is safe. And probably that operating scenario requires that ICC Max and CEP and TVB are all turned on, not turned off because the motherboard wants to run a sketchy undervolt. But, you know, I don't know for sure. Like, it is entirely possible that 1.498 volts, as spec'd by Intel at the factory for the 6 gigahertz speed on the CPU, is actually not safe. But I have no way of knowing that. And it is true that motherboard manufacturers have been disabling basically all of the safety features in order to make sure that, like, in order to get their undervolts to work. Especially like CEP and IC. Well, I don't even think ICC Max would be annoyed about the undervolting, but CEP gets very upset about it, as I've demonstrated. So, yeah. So if you want to try these settings, you can. But they're very much like at your own risk. Because I don't have any inside information about what's going on with this. And I'm gonna just assume that like Intel hasn't like completely botched the default vid tables, because they are shipping CPUs that have vids all the way up to like 1.5 volts or higher than that, especially on the 14900 KS chips. So, you know, if Intel is willing to put 1.55 volts into the vid table, like you would hope that it's not going to destroy the CPU, because that would be pretty stupid. Anyway, yeah, that'll be it for this video. Ended up being way longer than I wanted it to be, but this is unfortunately a complicated topic, I guess. And yeah. At the very minimum, I hope that like my settings here help you solve the instability. Yeah. On the degradation side of things, like I don't know. I guess like I mentioned earlier in the video, if you're paranoid about degradation, give up your single core boost. Set the lower the ICC max, lower the temperature limit. Don't use the 400 amp ICC max. Basically, use like 300 or something. And I guess if you have a lower core count CPU, like you would want to set the ICC max kind of proportional to the core count, I would assume. Actually, I wonder if the Intel docs have that. Man, this video just keeps getting longer. 16, 12. Oh, no, the 12 apparently 307. Right? Like it says right there. So, yeah, I guess you could use that. And that's kind of it. Oh, wait, we did manage to go over the CPU package. Yeah, see? So the thermal throttling just isn't that fast. I don't know why it only maxed out at 90 here. Oh, these are enhanced sensors. I guess they're faster or something? Anyway. Yeah. So, hopefully this is somewhat helpful. Hopefully it fixes your instability. If it doesn't, then I'd love to hear about it, because my experience with Intel CEP is that once you turn it on, you basically can't crash anymore. So yeah, and that's it. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And that's it for the video, so thank you for watching, and goodbye.